Write a definition for the function that is graphed below. All right, so what they've done here is sort of written out a piecewise function, and they want us to define it or write the function out on paper. So we have, it looks like a graph that does not include this point, but it does include every point on this horizontal line segment. And then likewise for this little line segment, it looks like it includes all those points, even the endpoints. Those are both included. So we have to define the function on the number line. So the first thing we need to do is to figure out its domain, right? So you have to think about, what pieces of the function exist and how do we define them on the x-axis. All right, so I'm going to label this piece over here part 1 and this piece here part 2, right? So the function consists of two pieces. So for f of x, we're going to say that it's equal to these two parts. And when I look at the first part, I would say, well, that looks like a line, right? It looks like a line segment, so I should be able to determine its equation, and I should be able to do that by simply saying, okay, what's the slope and what's the y-intercept? Well, I can see that the y-intercept is given to us as 0, 0, because it's touching the y-axis there, right? Now, what's the slope? Well, the slope, remember, is a simple formula for us. It's just the difference between the y parts of the points, so 0 minus 1, divided by the difference between the x parts of the points. So in that case, it'll be 0 minus a minus 2. So for that, it'll be negative 1 over positive 2, which is, of course, negative 1/2. All right, now from there, we can then write the equation of the line in y equals mx plus b form. Right, so mx plus b form. For us, that'll be y is equal to negative 1/2 x plus 0, or in other words, just negative 1/2 x. So the first part of the function is just negative 1/2 x. Now the thing to figure out, though, is what part of the number line is devoted to that. Well, it looks like it goes strictly from negative 2 to 0 on the x-axis, right? So on the x-axis here, we're going from negative 2 up to 0, and we don't use any other points for that little line segment. So I'm going to say that this will be true for x's that are between negative 2 and 0, but we want to include negative 2 and 0, so I'm going to put the equal to signs on those inequality symbols, right? So now it goes from negative 2 to 0 inclusive. All right, so remember, when the x is in the middle of that statement, it means that you're talking about x values between those two numbers. So you surround the x by less than symbols to show that x is between those two values that you're putting there. And if you want to include the values, you put the equal signs, right? Okay, so that is our piecewise function, at least for the first part of it. Let's do part 2 then. For part 2, it looks like we have a horizontal line segment, and it's horizontal, so that means it's a constant essentially. And all we have to do is figure out where does it pass through the y-axis to figure out which constant it is. So in this case, it looks like it's passing through the y-axis at y equals 2. Now, of course, it doesn't actually pass through the y-axis there because it's not actually defined at that point, but we can see that all the points on the line have y-coordinate of 2, as illustrated by this point here, 3, 2. The y-coordinate is 2, so that means that horizontal line is the line that's defined by the collection of y values that are equal to 2. Okay, good. So we have the collection of points that have y value equal to 2. That's the function f of x is equal to 2, so the second part is just literally f of x is equal to 2. But we still have to define its domain. So that piece of the function will range from 0 on the x-axis. So this is important, right? We're talking about where does this kind of begin, right? Well, it begins on the x-axis at 0, right? So it begins at 0, but we don't include that, right? And it goes up to infinity. It looks like it keeps going forever. Now, we don't want to write it in this type of notation, so we're going to use the notation we used above. And the way to do that, again, is to surround x by less than symbols, right? Okay, so let's surround x by less than symbols. This says x is between these two numbers. Well, it's between 0 and positive infinity. And this time we do not include either the 0 nor the infinity, right? So basically our domain for that piece is from 0 to infinity without including 0. And that's it. That's our function.